acting at a point are in equilibrium. Find the angle between the 12 Newton and then the 15 Newton force. So we have the 9 Newton force, 12 and 15. And they are in equilibrium, meaning they are, when forces are in equilibrium, it means that their total effect or the net force or the resultant force is equal to 0. Now, the first method or way out is that, you see, 15, 12, and 9 obey Pythagoras theorem. And so we term these three pairs of values to be Pythagorean identities. They are termed as such because they obey Pythagoras theorem, meaning that we can represent these three forces as the sides of the right angle triangle. We can represent them because they obey Pythagoras theorem. We can represent them as the sides of the right angle triangle. Of course, the longest side has always been the hypotenuse. So it means that the hypotenuse here is 15 Newton. Okay, the opposites can be 9 or 15, depending on 9 or 12, depending on whether you bring the 9 here or the 12 here or the other way around, it will still work. Okay, and this is because they obey Pythagoras theorem, meaning that if you square 15, it must be equal to the square of 9 plus the square of 12. So when you have three values and they obey Pythagoras theorem, they can be represented as the sides of the right angled triangle, and they are Pythagorean identity. Gideon, your hand was up.
So we wanted to ask why they can be said as Pythagorean.
Gideon, I'm listening.
So please, I wanted to ask why it obeys the Pythagorean law.
This is it. If you square 15, it will be equal to the sum of the squares of the other two sides. That's why they are Pythagorean triplets or identities. Okay. Other numbers are 5, I think 5, 4, and 3. 5 squared is equal to 4 squared plus 3 squared. So 5, 4, and 3 can also be represented as the sides of the right angle triangle. So if you have 3 sets of numbers and the square of the bigger one is equal to the sum of the squares of the other two, they are Pythagorean triplets or identities. Please, class, are you okay? So if you understand this, you can quickly represent these three forces as the sides of the right angle triangle, and then determine whatever you are being asked for. The question asks that we have to find the angle between the 15 and then the 12. So it means that this will be the angle, theta. So if that is the angle in question, then when I take the cosine of the angle, which is the adjacent 12 divided by the hypotenuse. Okay, and this is also equal to 4 on 5. 4 on 5 is equal to 0.8. Therefore, theta is equal to the cos inverse of 0.8. This is equal to 37.8 degrees or so. Approximately that is. Please confirm for me. Cos inverse of 0.8.
36.86.
Okay, 36. 36.9, approximately 37 degrees. Another way of doing the same thing, assuming I don't know that they are Pythagorean triplets, which other way can I solve the same question? I can draw them to represent to obey the Pythagorean law of vector addition. So this is one of them. Okay, let me bring it up here. This is one of them. This is another. Then I want to resolve them in the shape of a parallelogram so that I can determine their resultant. So this is 9 Newton. This is also 12 Newton. By doing this, this will also be 12. This will also be 9. Meaning that the resultant can be drawn from their common point, from the diagonal at their common point to the other point. So this is the resultant. Okay. This is the resultant, which is equal to 15 Newton. The angle between the 9 and 12, this is theta. I'm asked to find the angle between the 12 and 15. So this is alpha. Okay. Now let's use the cosine rule to find theta first. Let's use the cosine rule to find theta first, meaning the square of the resultant is equal to 9 squared plus 12 squared plus 2 times 9 times 12 times cosine of theta, the angle between the 9 and 12. The resultant is 15. So 15 squared is equal to 81 plus 144. This plus what is 18 times 12? 18 times 12.
316.
Okay. 316.
116.
Okay. 216.
Yes, sir.
216 cos of theta. Sum up this for me. This is 225. 81 plus 144.
225.
225.
Come again.
225.
Okay, 225 is equal to 216 cos of theta. This is 0, so we have cos theta equal to 0. Therefore, theta, which is equal to the cos inverse of 0, cos inverse of 0 is 90. So it means the angle separating the 9 Newton force and then the 12 Newton force is 90. Because this is a parallelogram, the opposite equal angles of a parallelogram or opposite interior angles of parallelogram are equal. So this angle here is 90, so will be this angle here. Meaning this plus this must also be 90. Quantua,
Service, I have a question.
go ahead.
So what about the 216 that was attached to the cos theta?
Oh, once the left hand side is 0, when you divide 2 by 0, that will still be 0.
Okay.
So if this is 90, okay, if this is 90, this angle here is also 90. Because this and this are parallel sides. Meaning this will also be 90. Okay. The angle here will also be 90. Class, are you following?
Yes, please.
Good. Now, we can use sine rule to find the angle between 15 and then 12. We can use sine rule to find the angle between 15 and 12. So sine of alpha divided by 9 Newton is equal to sine of 90, which is the angle opposite to the resultant, divided by 15. Sine of alpha is 9 over 15, since sine 90 is equal to 1. Therefore, we have 3 over 5. 3 over 5 is equal to 0.6, isn't it? Therefore, alpha is equal to the sine inverse of 0.6. Please, what is the sine inverse of 0.6?
36.86.
36.86. Approximately 37. The value is the same. Some of you also solved the same question with another interesting method, which was also correct though. If you have a right angle triangle, or a triangle, any kind of triangles. And then, assuming this is the side A, B, and C. This is theta. This is alpha. And this is beta. The cosine rule can also be applied to this if I'm looking for C, the square of C, please here, alpha, theta, and beta are acute angles. That's the rule. They are acute angles. So if I'm looking for C, the square of C is equal to the square of the other two sides plus 2 times AB cos of theta. Okay, it can also be minus 2AB cos of the corresponding obtuse angle, cos 180 minus theta. Both ways. So this is the method some of you also use in. So assuming this is 15, this is 9, and this is 12. And you have to find the angle between 12 and then the 15 Newton. Then it means that when you take 12 squared, or yes, 9 squared, since you are interested in this angle, 9 squared is equal to 15 squared plus 14 squared plus 2 times 15 times 14 times cos of beta, the angle opposite to the 9, which is the angle between the 12 and the 15. 81 is equal to 225 plus 144 plus, what is 2 by 15 by 14? What is 2 by 15 by 14?
210.
Is that 210?
Yes, please.
120.
220 or 30. Oh, sorry, there I've noticed it. It's 12, not 4.
420.
Hold on, it's 12. Let me correct this. This is 81, 225. Please, this is 12, not 14. 12 squared. Okay.
Sir,
So what?
please, isn't C supposed to be 15?
Come
15
again.
Newton. Isn't not C supposed to be 15 Newtons?
Which one? Is it? Come again.
It says C is equal to 15 Newtons, but there is 9 square over there.
Because I'm using 9 because we are looking for this angle between the 12 Newton and then 15 Newton, which is opposite to 9. So if you are looking for this angle beta, you must use 9 squared. If you are looking for theta, it must be 12 squared. If you are looking for alpha, it must be 15 squared. Marilyn, are you okay?
Yes, sir. Thank you, sir.
So the angles goes with the size you are actually considering. So 225 plus 144, okay, plus 30 times 12. What is 30 times 12?
360.
Okay, so 360 cos of beta.
Sir.
So 81 is equal to, let's sum up 225 and 144.
369.
369 plus 360 cos of beta. So 360 cos beta is equal to 81 minus 369. What is 81 minus 369? That's negative
Negative 288.
negative 28. Negative 288. Divided by 360. Divided by 360.
Negative 415.
Okay. Is that negative 4? I'm listening.
Negative 4/5.
Which is 0.8. Therefore, beta is equal to the cos inverse of negative 0.8. What is the cos inverse of this?
One
36.9 degrees.
Come again.
36.9 degrees or 37.
143.
So actually it's 100 and
43.
143. Now I just told you that this angle is acute. Okay, so once beta, alpha, and theta are acute, and your beta is 143, then you must actually its corresponding obtuse angle is equal to its acute angle. So when beta would also be equal to, when we subtract this from 180, we have its corresponding acute angle. So 180 minus 143, and that must give us 37 degrees. Okay. So either the angle is its obtuse angle or its obtuse angle. However, if you use minus, don't forget, then you are relating to the corresponding obtuse angle. So some of you also apply this and it's also spot on. Please, is there any question? If you have any question to ask, quickly do so. So please, when you are given a question, okay, it's just read and then try and then understand. Then you apply the theories to this. All right. Our discussion today is on resolution of forces or vectors. Resolution of vectors into components. Resolution of vectors into components. Let me clear my subheading and then bring it. Resolution of vectors into components. Now, the cosine rule, the sine rule is limited. The limitation of the cosine rule and the sine rule is that you can only apply it to two forces or two vector quantities. Then you resolve it into a triangle or a parallelogram to find the resultant. Okay. Now, if you are given three vector quantities that act at various angles, you cannot use the cosine rule. So, or the sine rule. So if you are given about three forces that act at various angles on a body or at a point, you cannot use the cosine rule. So the cosine rule, the sine rule applies to two concurrent vectors that act at a point or on a body. So example, I have a force, one force acting at an angle of maybe 45 degrees from the north. This is north, so this angle is 45. We have another force, this is F1. We have another force acting at an angle of 180 degrees from the north, F2. And another force acting at an angle of 270 due west. And the question is that this is F3. The question is that find the resultant. Find the resultant of these forces, of these concurrent forces and their direction. And their direction. This is where the limitation of the sine rule and the cosine rule comes in. Okay, so you must use the concept of resolution of forces into components to solve when you are faced with a problem of this nature. Please, is that okay? Hello, class, are you there? Emelda, Anita.
Yes, sir.
Yes, sir.
Because of network issues, let me be hearing from you to be sure you are around. Please let me take attendance, okay? And get back to me. Anita, I did not submit your work. Emelda too. Yasmin, Valerie, Buddy, Priscilla. Why? What happened? You over enjoyed Easter. Either you too. Then the guys, I'll go through the list. All right. Let's continue. Okay. Now, one key thing you must understand is that if a vector is directed along any of the axes, west, east, north, south, it means that the vector would only have one component. So on this axis, which I'm indicating with different colors, this is north, south, west, and east. If a vector quantity is directed along any of them, so example, a force is here. If we are to express F1, F2, F3, F4 into components, F1 would only have a vertical component and 0 horizontal component. So the component of F1 would be equal to, we represent them as the coordinates, okay, as a column vector, X, Y. So F1 hold on. Okay. So as I said, if you are to represent the forces on the Cartesian plane, my network Zoom quit or quitted unexpectedly. So let me redraw. So north, south, west, east, or y, positive y, minus y, and so on and so forth. So if a vector quantity, let's use forces, is directed along any of these cardinal points, this F2, F3, then this is F4. And we are to represent the components of each of the forces in a column vector, okay, in a column form, X, Y. F1, because it's along the vertical, would only have a vertical component and no horizontal component. So its horizontal component, which is X, will be 0. Its vertical component will be positive F1. This is similar to you being upright and being asked to call your height horizontally. Once you are standing upright, you have no horizontal height. So your horizontal height is 0, but your vertical height is your whole height. Okay. F2, on the other hand, will be equal to, yes, F2 seems to be lying along the x-axis or along the west-east axis. So it will have a certain horizontal component, but no vertical component. So X will be F2 and Y will be 0. Please, are we following?
Yes, please.
Okay. F3, on the other hand, is also along the vertical. It will have no horizontal component, but a negative vertical component. Negative because this is lying along the negative x-axis. Conventionally, the south axis is considered to be negative. Then F4, on the other hand, would have horizontal component, which is negative F4, because it's along the negative x-axis, and 0 vertical. Okay, so these are the resolution of forces into components when they happen to lie on the x, y axis or the cardinal points. Now, if any of them happen to be at an angle to any one of the cardinal points, example, we have F5, but this time around F5 isn't lying on any of the axes, but it makes a certain angle with any one of them. I want to improve aesthetics, so let me use a straight line. I'm told that the angle this makes. Hello, Lordina, mute yourself. If you are not asking question, please mute yourself for me. The angle this makes with the north, I'm told, is theta. And the angle F5 makes with the east, I'm told, is alpha. The moment it doesn't lie on any of the cardinals, but it makes a certain angle with either the x or the y, we can confidently resolve this into components. How do we do that? In this case, let me clear my F1 because the issue at hand is only F5 making a certain angle with it. So I must, using the angles, whether to the north or to the south or to the east, okay, I must resolve the force F5 into 8 various components. Now, this component, with respect to, it has to do with the forearm, with the angles in question. Using the angle theta, this side is the opposite, and the opposite would always be perpendicular with the adjacent. With respect to angle alpha, this is the opposite, and it's also perpendicular to the adjacent. Okay. Now, I can use any of these angles to resolve F5 into its vertical component and its horizontal component. Let's indicate the component. The component also obey the triangle law of vector addition. Okay, so this must be directed here, and this also must be directed here, so that they all obey the triangle law of vector addition. So using angle alpha, using the angle alpha, the various components, let's indicate this as Fx. And let's indicate the opposite to be Fy. If I'm looking for either Fy or Fx, Fx is an adjacent, so I'll have to take cosine because I have the angle, I have the hypotenuse. I'm looking for the adjacent. So Fx will be cosine of the angle alpha being equal to the adjacent, which are named as fx, divided by the hypotenuse, which is f5. Therefore, fx will be equal to f5 times cos alpha. And this is the horizontal component of the force F5. The horizontal component of the force F5. Okay. Its vertical component on the other hand. So concerning the vertical component, class, will I use cosine, sine, or tangent? Which appropriate trig ratio must actually be used here? Will it be sine, cosine, or tangent? Yes. Anybody? The vertical component, class, Fy. Do I use sine, cosine, or tangent?
Tangent.
Okay, Frank is saying that we are to use tangent. Let's use it and see if that will help. Frank, what is the tangent of an angle?
The opposite over the adjacent.
So tan alpha, Frank said, is the opposite. Yes, opposite is Fy. Adjacent, we don't know yet. Frank, yes, your argument may be that we found Fx. You are right. But we are working with the knowledge that we have the hypotenuse and the angles, and we are looking for Fy and Fx. So we have the angle and the hypotenuse. We have no idea of the adjacent yet. Is that okay?
Yes, sir.
So based on what we have, obviously we are to use sine. We are to use sine. So when we take the sine of alpha, sine of alpha, it is equal to the opposite Fy divided by the hypotenuse F5. Therefore, Fy is equal to F5 times sine of alpha. And so in representing F5, okay, to its vertical and then horizontal components, we have it as Fx is F5 times the cosine of alpha, then Fy is also F5 times the sine of alpha. These are the components of the force F5. Frank?
Can there be a case that it could be the tangent, F5 tangent alpha?
No, you see, we are using, I said we have the hypotenuse and the angles. Okay, so we are using what we have to determine the unknowns. That is why we are not considering tangents. Okay, you know, tangent isn't involved in when we talk about tangent, we don't mention hypotenuse because tangent is the ratio of the opposite side to the adjacent. Are you okay? Frank, are you okay?
Yes, sir.
We can also do the same component using the angle it makes with the north or the y-axis. Don't forget, alpha is the angle the hypotenuse or the force makes with the x-axis or the east. We can equally do the same thing using the angle it makes with the north or y-axis. That is theta. So using the angle theta, using the angle theta, the same component, don't forget the opposite side to theta is still fx because it's along the y-axis or along the east. Then the adjacent side of theta is still fy because it's along the y-axis or north. So if I'm to using the angle theta and I'm looking for fx, must it be sine or cosine, class? Using the angle theta and I'm looking for fx, must the trig ratio be sine or cosine?
It's fine.
Gideon, your line is breaking. Using the angle theta, if I'm looking for fx, will I use the trig ratio sine or cosine?
Sine.
So it must be sine because fx is the opposite, whereas we have the hypotenuse. Giovanni,
So please, why is f5 equal to fx and fy?
why is Giovanni, you are not alert. Okay,
So
so
please, f5.
we are resolving f5 into its x and y components. Its x component is what I'm calling as fx. Its y component is what is being called as fy. So you find fx and fy and put into the column vector form. Okay. So using theta, this side, you must use sine of the angle. So sine theta must be equal to the opposite, which is fx divided by the hypotenuse, which is f5. Therefore, fx in this case is equal to f5 times sine theta. Okay, so this is the horizontal component. You see, this part is actually the vertical component of the angle fx. But because it's along the x-axis, it is termed as fx. Now, if I'm to look for fy, fy here is the adjacent of the angle. So obviously, you need to take cosine of theta. So cos theta is the adjacent, which is fy, over the hypotenuse, which is f5. Giovanni.
So please, the question said find the angle between the forces. So isn't the angle the cos theta?
Giovanni, I've not given a question. I'm only taking you through how to resolve forces into its components when the angle it makes with x or y is given and then the force is given. It has nothing to do with the earlier questions yet. Is that okay? When I finish going through the theory, I'll give you a question and you'll be able to apply it well. Are you okay?
Yes, sir.
So fy here is f5 times cos of theta. Okay, now f5 resolved into x and y components is equal to our fx here is f5 sine theta, then f5 cos theta. What you must note is that this is equal to whatever we had when we took the angle it makes with the x. So F5 cos alpha, F5 sin alpha is also equal to F5 It's equal to F5 sin theta and then F5 cos theta. So the rule is that if you are using the angle, the vector mixed with the x-axis, okay, the x and y component becomes cos sine. Meaning if you are using the angle, the vector mixed with the x-axis, the order of the component becomes cos sine. If you are using the angle, the vector mixed with the y component or y-axis or the north, it is sine cos. And whether cos sine or sine cos, the answer must be the same. Let's solve a real example. Let's solve a real example. We are given we have this and we are told that this is the y-axis or north, this is the x-axis east. A vector makes an angle of 30 degrees with the north. If the angle it makes with the north is 30, what angle will it make with the east? Imelda, Anita, Yasmin, Ada, and then the gentleman. The force is 100 Newton, or the vector. If the angle it makes with the y-axis or the north is 30, what angle will it make with the east or the x-axis?
60.
60. So 30 is the theta, 60 is the alpha. Good. And our task is to resolve this force into 8 vertical and horizontal components. And so I can use the angle, either the angle it makes with the x or the angle it makes with the y for this assignment. Any of the stated angles must give me the same results. So, and the components must obey the triangle law of vector addition. So this plus this is equal to the resultant. The vertical component must be perpendicular to the horizontal component so that they form a right angle triangle. Now, using angle, Marilyn, are you there? The two Marilyns, Kujo and Osei Tutu.
Yes, sir.
Using angle, the angle 60 degree. F Y. Y because this is along the y-axis. And then Fx. As that Fx is equal to, if I take cosine of the angle 60 or 60, degree. It is equal to the adjacent, which is fx over the hypotenuse. The hypotenuse is the angle, is the force 100 Newton. Therefore, fx is equal to 100 times cos of 60 degrees. Now cos 60 is half. Therefore, Fx is equal to 50 Newton. That is the value of the horizontal component using the angle 60. Now, if I want the vertical component Fy, I must take sine of the angle 60. Sine is the opposite Fy over the hypotenuse 100. Therefore, Fy is equal to 100 times sine 60. Sine 60 is root 3 on 2. So this is equal to 50 times root of 3 Newton. And that is if I want to leave my answer in sets. You can leave it in fraction, in decimal too. Priscilla, are you there? Okay, so using the angle 60, look at the component of the force. The force 100 Newton. The component, the vertical component is 50. Sorry, the horizontal component is 50, whereas the vertical component is 50 root of 3. Please, never in any case must you see this to be 50 over 50 root 3. No. Using the angle 30, using the angle 30 degrees, which is this angle. The opposite to the angle is still fx because it's along the x-axis. The adjacent to the angle is still fy because it's along the y-axis. Therefore, if I want the opposite, sine of 30 degrees, which is equal to fx over 100. Fx is therefore equal to 100 times sine 30. Sine 30 is equal to cos 60, half. So this is also 50 Newton. Okay, then the adjacent, which is Fy. If I take cosine of 30, is equal to the adjacent, which is Fy on the hypotenuse 100. Therefore, Fy is also 100 times cos 30. Cos 30 is root 3 on 2, so 50 times the root of 3. Okay, class, it is now obvious that whether you use the angle it makes with the y-axis or the x-axis, the value is still the same. The answer is still 50 for x and 50 root 3 for y. So whichever way you look at it, you must get the same results. Class, is that okay?
Yes, please.
If you have any question, ask me before I ask you questions. Giovanni.
is in the previous page. I'm still confused to how F1 is equal to 0 as the X component and Y as the F1 component. I still don't get it.
Okay, Giovanni, you will pay me for enough use of energy. Okay, let me even refer to the previous, if only is there. Oh, I think I explained it. Giovanni, come up with your question again.
I'm still confused as to how you move for F1, the X component was 0 and the Y component was F1.
Okay. Giovanni. Hello.
Yes, sir.
If you are lying, if you are standing upright, okay, and somebody asks you that, Giovanni, what is your height horizontally? What will you say? If you are standing upright on your feet, and somebody asks that, what is your height horizontally? What value will you give?
0.
0. Because you do not have height horizontally. But your height vertically is your full height. So we have this force, F1, along the vertical. And we want you to resolve this, like divide this force into vertical and horizontal components. Because the force is upright, clearly it has 0 horizontal components. So 0. Okay. What about the vertical component? The vertical component is your whole height, F1. Are you okay? Giovanni, are you okay?
Yes, sir.
Another way of doing the same thing is that, you see, when you are looking at the angle the force makes with the y-axis, or the vector makes with the y-axis, I told you that in using the angle the vector makes with the y-axis, the order of the component is sine cos. And in using the angle it makes with the x-axis, the order of the component is cos sine. Please, class, do you remember? Class, do you remember this? What we just discussed? If you use alpha, alpha is the angle it makes with the x, theta is the angle it makes with the y. And in using alpha, the order of the component becomes cos sine. When you use theta, that's the angle with the y-axis, it is sine cos. Okay, we can also use this idea to do the same thing. Giovanni, what angle does F1 make with the y-axis? What angle does it make with the y-axis?
Pardon?
What angle does F1 make with the y-axis?
180.
Open your eyes. Class, anybody? What angle does F1 make with the y-axis? 0.
0.
It's 0. Giovanni, are you okay? So I can, using the angle it makes with the y-axis, I can also resolve this into, as I said earlier, if you are using the angle it makes with the y-axis, the order is sine cos. So F1 sine 0, then F1 cos 0. That is using the angle it makes with the with the y-axis. What is F1 sine 0? Sine 0 is equal to 0. Okay, so 0 times F1 is 0. Then cos 0 is also 1. F1. So I have, these are the components of F1. Same as the analogy we made. We can also use the angle it makes with the x-axis. And what angle does this? What angle does F1 makes with the x-axis? Plus, what angle does F1 makes with the x-axis?
90 degrees.
So this is 90 degrees. So if you want to use the angle it makes with the x-axis, I told you the order of the component becomes cos sine. This one. So take notes. So it means that this F1 can also be F1 times cos of 90. Then F1 times sine of 90 as a component. Cos 90 is 0. 0 times F1 is 0. Sine 90 is 1. 1 times F1, F1. So whichever way you look at it, the value is still the same. Giovanni, that's your explanation. Okay, class, your work. We have this force. Whose magnitude is 200 Newton. It makes an angle of this is 45 degrees to the y-axis and also another 45 degrees to the x-axis. Resolve this into vertical and horizontal component. So resolve this force into the vertical and horizontal component. Start with. Godfred, are you here?
Yes, sir.
Today you are quiet. What's the secret? You are quiet today. So I have Ida, Akosia, Anita, Augustine, Barak, Caleb, Daisy, Ifwa. Ifwa, Estra, Frank, Rempoma, Gerard, Gideon, Giovanni, Godfred, Isaac, Jacob, Jaila, Jadine, Jessica Johnson, Kingsley, Lordina, Marilyn, Ujo, Marilyn Osei, Mary, Michaela, Michelle. Michaela, where is Blessing? Miles, Nana Kwame, Wajua, Ohene, Paddy, Emelda, Valerie, Yasmin, Danielle, and Gideon. And Ella Davis is here too. Yes, Godfrey.
Sir, please, I don't understand.
Which one? The question?
Yes, please.
Don't worry. Yes, but just look at how we discuss the example, how we resolve theta and alpha into the two components. We'll discuss it afterwards.
For the 10 kilos. And let go down 1 minute a month, let go down.
God, unmute yourself. Are we through? House, are we through?
Yes, sir.
No one is talking.
Yes, sir.
Okay. Then let's discuss it. So there are a lot of ways to go around this question. Okay. I can use the angle it makes with the north or the negative y axis or the negative x axis. Whichever way you want to use. If I want to use the angle it makes with from the north, it is the whole angle would be 180 plus 45. So if I want to use the angle it makes with the north from the north axis or positive y axis, it is 180. The whole angle is 180 plus 45. Imelda, what is 180 plus 45?
225.
225. Imelda, not 225. Okay. So now I earlier also said that if you want to use the angle it makes with the y-axis, the order is sine of the angle and cosine of the angle. If you want to use the angle it makes with the x, it is cos sine. Do not forget this. So my first approach is that maybe I want to use the whole angle it makes with the north axis or the positive y-axis, and it must be 200 sine of 225, and then The y component is also 200 times sine of 225. Sorry, cos. Wilfred.
Please, where is the 200 coming from?
The magnitude of the force. The force is 200 Newton. So a force of 200 Newton acts at an angle of 225 from the north. So the force given is actually, look at the drawing, is 200 Newton. Are you okay?
Yes, sir.
All right. So Imelda, what is 200 times sine 225? Then somebody else should also do the 200 times cos 225 for me.
Negative 141.421.
Negative 141.421. Okay, 4 Newton. What about the 200 cos 225?
Say the same thing.
Minus 141.4 Newton. So method 1. The second method is that I can also use this angle it makes with the negative y-axis, which is, or with the sum, which is 45. Okay, but I should not lose sight of the fact that if you are using the angle 45, if you are using this, this will become the fx. Fx because though it's the opposite, but it's along the negative x-axis, and this side is fy. Fy because it's along the, okay, so sine of 45 is equal to fx over 100. Fx, sorry, over 200. Fx is equal to 200 times sine 45. However, look at this part we are calling as fx. It is along the negative x-axis. Okay, and so you must indicate negative here. So you bring a negative because it is along the negative x-axis. Imelda, what is 200 times sine 45? Root 2 on 2. So 100 times root 2. 141.4. Yes. Minus 141.4 Newton for fx. If I want fy, because fy is the adjacent to the angle 45, cosine cos 45 adjacent fy over hypotenuse, which is 200. Fy is equal to 200 cos 45. Don't forget this side we are calling as fy also lies within the negative y-axis. So it must be here. Class, are you following me? Are you?
Same.
So we still have negative 100 times root 2. Root 2 is 1.414. So the value is still the same, minus 141.4 Newton. So whichever way you want to look at it, the value is still the same. Who does not understand this? Emel, ask again.
Say, I don't understand.
Who told you?
Say myself.
What's the problem?
From the beginning.
Yes. You see, I solved it using two different methods. I use the angle, the whole angle the vector makes with the positive or the north, because for vectors, angular measurement is taken from the north. So I can take the whole angle the vector makes from the north, because vectors angular measurement is taken from the north. Okay, and don't forget the north is also y-axis. So if you are using this whole angle, then the order is that if you are using the angle the vector makes with the y-axis, it is the order of the component is sine cos. So the product of the force or the vector, which is 200, and the sine of the angle it makes from the north, 225. That is 180 plus 45. And then 200 cos of the same 225. This would give you the value without bringing in the negatives, without looking at the quadrants, okay, the component force. That is why when we did this, we are getting the negative 41.4, okay, direct. If you consider other angles it makes with the x and the y, yes, that is when you must consider the quadrants within which the component falls as well. So when we use the angle it makes with the y-axis, still the order must be sine cos, but this would be 200 sine 45, okay, 200 sine 45, which is x, and it falls within negative x-axis. So minus must be here, else you have it as positive, and another minus 200 cos 45. If you use the angle it makes with x, the same thing, you get the same answer. But you shouldn't forget about the quadrants within which the vector falls. Imelda, are you okay?
Say somehow.
Okay, another question. This is the whole nitty-gritties of resolution of vectors into components. When you understand this, if I give you 100 forces acting at a point, you will still do it. Okay, so this time around, it makes an angle of 60 degrees with the y-axis, meaning it makes an angle of 30 with this. Look at the quadrant, and this is the magnitude of the force is 50 Newton. Resolve this into vertical and horizontal components. Start with. I wish you can use more than one method. Anita, are you there? Daisy. Daisy.
Yes, please.
I hope you are not dozing.
No, please.
Okay. So resolve 50 Newton acting at an angle of 60 degrees anti-clockwise from the north. resolve that into components. I wish you can solve this using two different methods. I'll be very happy if you could do that for me. True. Are you true? Hello, are we true? Gideon, what are your answers?
It's negative 43.3 and 25.
Gideon, take your time. Negative.
Negative 43.3 and 25.
I heard 25 and negative something. Negative what?
40.3.
Oh, your line is breaking, Gideon. Okay, so Augustine is negative 43.3 and 25. Imelda, what's your answer?
Sammy, I was waiting for you
To do what?
to solve it.
Giovanni, what's your answer?
Sir, please, negative 43.3 and 25.
Marilyn, what's your answer? Okay, Kingsley.
Negative 43.3 and 25.
Okay, Marilyn, what's your answer?
That means I do not know.
Okay, so let's see. So first, my first method I want to use is that I want to use the angle it makes with the x-axis. The west is also minus x, don't forget. So if you use the angle it makes with the negative x, don't forget the other, using the angle it makes with x, the other is cos sine. So we have 50 cos 30, but this is along the negative x. So let me draw something. So using this angle, this is the opposite. This is the adjacent or horizontal. So fx would be cos of 30 fx over 50. And because it falls within the negative x this is negative. Okay. Cos 30 is equal to root 3 on 2, which is 0.866. So when you multiply 50 by 0.8660, Melda, or root 3 on 2, or 25 times root 3. Imelda, I'm waiting for you. Fx of fx is equal to 43.
Negative 43.3.
Negative 43.3. And when the vertical component obviously sine. So sine of 60 degree is the opposite, which is Fy over the hypotenuse, which is 50. Therefore, Fy, oh, sorry, 30. Fy is 50 times sine 30. Sine 30 is how? This is 25 Newton. Okay, so your answers are correct. The other way out is that we can use the angle it makes with the north or y-axis. And when you use that, we have, when you use the angle it makes with the x, with the y-axis, the x, fx will be equal to 50 sine 60. However, this fx also lies within the negative, so minus sine 60 root 3 on 2, or 0.8660. So it would bring us to the same value, minus 43.33. Then the horizontal component, which is Fy, will be cos of 50 times 50 times cos of 60. Cos 60 is half, so 25. And this is positive. It lies within the positive y-axis. So, okay. I can also do the same thing by considering the whole angle it makes. The vector makes from this whole angle. Okay. So if this is 60, it means that this angle is 300. So the angle it makes with the y-axis or north is 300. So fx can also be 50 sine 300 degree and 50 cos of 300 degree, and the value will still be the same. You have negative 43.3. And so if you are given a question on vectors or forces, a number of them acting at a point, about 3-4 vectors, and you are asked to find their resultant force. Pick each and every force, resolve it into 8 components, horizontal, vertical, okay, and you can, when you finish, sum up all the horizontal components, sum up all the vertical components. So I'm going to give you an example to try. I'm giving you 3 forces that acts at a point at the same time. This is 1. Then the other one is that we have this force of magnitude 20 Newton. It acts at an angle of 30 degrees to the x. Then lastly, we have this force of magnitude 16 Newton. It acts along the, this is y, this is minus y, minus x, and this is positive x. Class, your question is that determine the magnitude and direction of the resultant force. So it's a task I want to give you. Read ahead and do it. So determine the magnitude and the direction of the resultant force. So the trick is that when you are given such a question, resolve each of them. Assuming this is F, let's assume that this is F1. This is F2. This is F3. So pick each one at a time, resolve it into its vertical and horizontal components. Okay. So resolve each vector or force into its vertical and horizontal component. When you finish, determine the summation of all x's. So F1x plus F2x plus F3x. Then the next method is that find summation of all y's. F1y plus F2y plus F3y. When you finish, you redraw. Supposing your summation of fx and fy were positives, you redraw them on the Cartesian plane. This is your x and y axis. So if they are all positives, then it means summation fx will lie along here. Summation fx. If summation fy after adding them is positive, it will also be here. Realign their direction and you realize that they are diagonal. will be, their resultant will be along the diagonal. So this will become the resultant. Okay, equal vectors. This side, when you draw equal vectors, must be equal to this, so that this is also summation Fy. R, therefore, R squared will be equal to square root of, okay, R instead of R will be equal to the square root of summation Fx squared plus summation Fy squared. And that will give you the resultant. The direction of the resultant is also the angle between either summation F of x or summation F of y. So assuming this is theta, when you take the tangent of theta, this is equal to summation Fy over summation Fx. Theta is equal to the tan inverse of this. And this will give you the direction to the x-axis. And when you subtract theta from 90, you have the summation, you have the direction it makes with the y-axis. So that's how to calculate or determine the direction. Class, are we okay? So just give it a try. Of course, we'll discuss it. But this is a guide. This is a guide to helping you. Next week, we'll solve about 1-2 examples. Then look at equilibrants, bring in the equilibrants of forces or vectors. Then we can say goodbye to vectors. Please, are we okay? And is there any question? Class, is there any question? All right. If there is no question, then this is where we draw the curtains on today's meeting. Okay. Have a very good or nice weekend. Please revise. I've noticed that you do not watch the video. Please, after lessons, spend time to review the day's video, and it will help in recapping some of the key facts that was not understood so much. Okay, so I beg you, spend time to watch the video. Imelda, are you okay?
Yes, sir.
Marilyn, are you okay? Spend time to go over the video. Godfred, I beg you. But I'm actually referring it to all of you, but I mean, some of you, okay, have to sound that, I mean, better to you. So we'll continue our next lesson on next week. Please do this assignment. If you're able to finish it on time, I can forward another one to you to try. Okay. All right. Take care of yourselves and bye-bye.
Bye.
Okay.